Today in this video, I'm going to talk about how to find the area of a regular polygon. So before we start, I would like to go over some basic vocabulary. And to do this, I'm going to use this polygon here, and I am going to draw in triangles. And remember, a regular polygon is a polygon that has all congruent sides and all congruent angles. So I have now divided this polygon into 6 congruent triangles. This segment that goes from the center of my polygon to the vertex of my polygon is called the radius. All radii of a regular polygon are congruent. Then if I draw in a segment from the center to the midpoint of a side, that segment is called the apothem. Then one more thing I want you to know is that the area formula for a regular polygon is 1/2 the apothem times the perimeter. So we are going to take a look at how to calculate the area when you are not given each of those pieces. Okay, here's my first example. I have a regular heptagon, or a polygon with 7 sides, and the side length is 2. And you can see that I've drawn my polygon and I've labeled my side 2. The next thing I would like to do is draw in one isosceles triangle. So to do this, I just simply connect the center with 2 consecutive vertices, and now I have an isosceles triangle. And to find the vertex angle, I do 360 divided by 7, and this is why. Because if I draw in all these radii, what happens is that I have 7 congruent triangles. The degree measure all the way around is 360. So I can find that vertex angle by simply taking 360 and divide by 7. Now I'm going to pull up my calculator as we go, because how we're going to use it's going to be important. We want to find the most accurate estimate of the area. So in my calculator, I would do 360 divided by 7, and that would be 51.43. And you can see that that is what I've written in for my vertex angle. The next thing I would like to find are the base angles of this isosceles triangle. Now remember, inside a triangle, all my angles sum to 180. So to find the base angles, I am going to take 180 and subtract my vertex angle and then divide by 2. But I'm going to use the non-rounded version or extended decimal that is in my current calculator currently. So I would do 180 minus, now I'm going to press the second key and then this dash key down here, second answer. And now I need to divide by 2 because my base angles of any isosceles triangle are congruent. So you can see that that comes out to be 64.29. Now again, it's really important that you don't round until the end of all of this, because you end up with pretty significant rounding errors sometimes. Now, the next thing I need to do is find the apothem. Okay, so I'm going to draw it in. And when I do that, I create a really nice right triangle with 64.29 as my base angle. Now, you can see in my work that I show here, I would like to find my apothem. My apothem is that segment that goes from the center to the midpoint of the opposite side. So tangent of 64.29 is the opposite over the adjacent side. And remember, this is the midpoint. So that adjacent side of that right triangle is 1. So tangent of 64.29 is a over 1, and a is equal to tangent 64.29. I plugged it into my calculator and I got that long extended decimal. Now, you will further notice, now I'm going to show you in my calculator what I do. I press tangent. Now wait a second, we've got to make sure we are in degree mode. Yep. So tangent of second answer. I don't want the rounded version of my angle. I want the extended decimal version to make it as accurate as it can be. And you can see that that comes out to be 2.076 blah, 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 blah. Okay. Notice in your directions, do not round the answer until you use it in your formula. I'm going to leave it sit in my calculator. Now, the perimeter is also something I need for my formula because the formula is 1/2 the apothem times the perimeter. The perimeter in this case is pretty easy to find because I know the side length and I know I have 7 sides. So my perimeter is 7 times 2 or 14. So we plug into our calculator here. Again, I'm going to do 0.5 times second answer because I want that extended version of my decimal times 14. So my answer is 14.54 square inches. Notice that when we are calculating area is measured in square inches, length is measured in single units, so in this case inches. So that is the first example I have of calculating the area of a regular polygon. I would like you to try this one. Press pause on your video, and when you're ready for the answer, press play again. So here are my answers. I've outlined for you the process that you should go through in order to find the area. So I had you first draw in your isosceles triangle. You can see that's what I've done here. I found the vertex angle. Remember, my vertex angle is going to be 360 divided by the number of sides, which is the same as the number of vertex angles I have. So in this case, there are 8 sides, so you should have gotten that your vertex angle is 45 degrees. Then the next thing I did was I found my base angle. So that is 180 minus 45 divided by 2. So that's 67.5. Then I found the perimeter. My perimeter is my side length, which was 4, it's given, times the number of sides, 8, 32. Now I need to find the apothem using trig. You can see that's what I have done here. I said tangent of 67.5 is opposite over adjacent. Notice my adjacent side is 2. It's not 4 because this side has gotten divided into 2 pieces. Now to find the apothem, I multiplied both sides by 2, and I got that the apothem was approximately 4.83. That's what's in this blank here. Now again, it's important to round at the end, so I'm just going to show you. When I calculate the area, I had already had tangent of 67.5 in my calculator. So I did 1/2 times the times my apothem. Wait a second, 67.5, the apothem is 4.83. Oh, I have to multiply by 2. There we go. So I have my apothem, 4.83. So now I'm going to multiply by 1/2 and then by my perimeter. And my perimeter was 4 times 8, or 32. So now the area of my regular polygon is 77.25 square centimeters. Here is a third example. In this example, we're going to find the area of a nonagon with side length 7 yards. Now remember, a nonagon has 9 sides. So again, you're going to draw an isosceles triangle, but in this case, I want you to notice I did not draw the entire nonagon. It's not necessary. I just drew that isosceles triangle that was a part of that nonagon, and it's right here. I followed the steps as I did before. I found my vertex angle by taking 360 and divided by 9. That gave me 40 degrees. Then I found my base angles, 180 minus 40 all over 2. That's 70 degrees. Then I found the right triangle leg. So it's not 7, it's half of 7, or 3.5. I found my perimeter. There were 9 sides. They were all 7 units. So I have 63 yards as my perimeter. The next thing I had to do was find my apothem. Tangent of 70 is equal to the apothem over the adjacent side, opposite over adjacent. Here, multiply both sides by 3.5. That gave me 9.62. Again, in my calculator, I have not rounded that measurement. Then I found the area by plugging in. So my area was 302.91 square yards. Now, in this example, really the only thing I did differently is I did not draw the entire polygon. I just drew the isosceles triangle within that polygon. All right, I'd like you to try this example. Press pause on your video, and when you're ready for the answer, press play again. Okay, here is my answer. You can see I've drawn in my isosceles triangle, and then I found my vertex angle by doing 360 divided by 13. That was 27.69. That's what I have labeled here. I drew in my apothem, and I also found my base angles. So my base angle is 180 degrees minus my vertex angle all over 2, or 76.15. I found my perimeter. The perimeter is the side length 10 times the number of sides, 13, so it's 130 meters. Then I found the leg of my right triangle, so that would be half of my side, or 5. And I found my apothem. So tangent of 76.15 is here, is equal to the opposite over the adjacent side, a over 5. Make sure you're trying this in your calculator, and remember, you are not going to round until the very end. So finding the apothem is 5, multiply both sides by 5, tangent of 76.15, and that is approximately 20.29. Plugging into my formula, I did a half times 20.29, but again in my calculator that's the extended decimal, times my perimeter 130, and I got 1,318.58 square meters. Here's my next example. I'm going to find the area of this regular octagon. This time the apothem is given. Again, we're going to draw our isosceles triangle first. That is what is here. I found my vertex angle. It's an octagon, so I did 360 divided by 8. That gave me 45. We found these angles earlier. Then I found my base angle by subtracting my vertex angle from 180 and dividing by 2. That's 67.5 degrees. Now, I have my apothem, so that's different than the last time. What I need to do is find the side of my right triangle so that I can use it to find the perimeter. So tangent of 67.5 is the opposite over the adjacent side, or 6 over x. Multiply both sides by x, and then divide both sides by tangent of 67.5. Plug it into my calculator. That's 2.49. Again, you're not going to round until the end. Now, to find the side length of my polygon, I have to multiply that by 2, because this is my side length here. Multiply by 2, that's 4.97. Then I have to use that to find the perimeter. So there are 8 sides in my octagon. I don't know why this is a G here, but then my perimeter should be 8 times my side length, or 39.76. Again, not rounded. We're going to leave this value in our calculator so that we can use it and round after we're done finding the area. So now plugging into my area formula, 1/2 the apothem times the perimeter, it's 1/2 times 6, because that apothem was given, times my perimeter. So you should get 119.29 square inches. Here's another example I'd like you to try. Press pause on your video, and when you're ready for the answer, press play again. Here is my answer. You can see that I drew in my polygon, and I was given the apothem. So in this case, I found my vertex angle, 360 divided by the number of sides. So that was 24 degrees. To find my base angle, it was 180 minus 24 divided by 2. That's this angle right here. Then I used it to find a side of my right triangle. Tangent of 78 is the opposite over the adjacent side, or 11 over x. I multiplied both sides by x and divided both sides by tangent of 78. So I got x is 11 over tangent of 78, or 2.34. To find my side length, I multiplied by 2. Then to find the perimeter, I multiplied by 15, or the number of sides in my polygon. Now I'm ready to plug into my formula. It's 1/2 the apothem, 11, which was given, times my perimeter, 70.14, which I'd calculated earlier. Remembering I'm using the extended version of that decimal. When I plug in and multiply, it's about 385.79, rounded to the nearest hundredth. So remember, also square millimeters. Here's my next example. I want to find the area of a regular 20gon with radius 3 centimeters. So in this case, I'm not given the apothem, I'm not given a side length, I'm not given the perimeter. The only thing I'm given is the radius. And the radius is the length from the center to the vertex in a regular polygon. So my first step is to draw that isosceles triangle and to label everything. I find my vertex by taking 360 and dividing by the number of sides, which is 18. To find the base angle, I subtract 18 from 180 and divide by 2, so that's 81 degrees here. Now I'm going to have to use trig to find both my side length, or side, the leg of my right triangle, and also to find the apothem. This leg is going to allow us to find the perimeter. So let's work with that first. So cosine of 81 here is the adjacent x divided by the hypotenuse 3. I multiply both sides by 3, and I get x equals 0.4693. I then multiplied that by 2 to get the side length, because that's what this is. That's 0.9386. Then to get the perimeter, I multiplied the number of sides times the side length, and that got me 18.7721. All along this way, I'm not rounding, and you'll notice that I wrote in quite a few decimals here, and I would also refer to my calculator later to put in as many decimals as I can. Now, I also have to use trig to find the apothem below. So sine of 81 is the opposite over the hypotenuse, or a over 3. Then I multiply both sides by 3, I plug into my calculator, and there is my apothem. Now, plugging into the formula, that's 1/2 the apothem times the perimeter. When I multiply, I get 27.81, rounded to the nearest hundredth. That's square centimeters. I'd like you to try this example. When you're ready for the, press pause, and when you're ready for the answer, press play again. Okay, so in this example, like our last one, we were given the regular polygon and the radius, not given a side length, not given the apothem. So we have to find all of that with trig. I drew it in my isosceles triangle. I found my vertex angle. It was 360 divided by the number of sides, which is 5. So I got 72 as that vertex angle. To find my base angle, I did 180 minus 72 divided by 2. That's 54 degrees. And that you can see here. I use this information to find the base, one of the legs of my right triangle, and then to further find the base of my isosceles triangle and then the perimeter. So here's where I'm finding the side length of my leg of that right triangle. It's cosine of 54 is the adjacent over the hypotenuse. X is the adjacent, 10 is the hypotenuse. We multiply both sides by 10. I got 5.88. That's rounded, but the extended decimals in my calculator. I multiplied by 2 to find the side length of my isosceles triangle. And then I multiplied by the number of sides, which is 5, to find the perimeter. Again, I have a long extended version of that in my calculator. I further used trig to find the apothem. Sine of 54 is the opposite over the hypotenuse. A is the opposite, 10 is the hypotenuse. I multiplied both sides by 10 to find the apothem, plugged into my calculator. I used the long drawn out decimals for both of these in this formula here. It's 1/2 the apothem times the perimeter. I plug in 237.76 is my answer. The units on this are square feet. In my next example, example 9, I'd like to find the area of the regular hexagon with side length 18. Now, in this case, I'm going to be able to find exact answers because I'm going to get some nice 30, 60, 90 triangles. Whenever you're able to get an exact answer, you should. My steps remain the same. I drew in the isosceles triangle and the apothem. So this vertex angle here was 360 divided by 6, which would have given me 60 degrees. So then my vertex angle was 60. I found my base by taking 180, subtracting 60 degrees, and dividing by 2. I found that was 60. When I draw in that apothem, what happens is I cut my side in half, and I also cut this vertex angle in half. So I get a really nice 30, 60, 90 triangle. Now my side length is 18. So the one side of my right triangle, one leg, the non-apothem leg, is half of that, or 9. Now I can use my 30, 60, 90 triangle relationship in order to find the apothem. Remember how this goes. The side across from 30 is A. The apothem is A root 3. The hypotenuse is 2A. So now if I know A is 9, I know my apothem is 9 square root of 3. So then I'm able to plug into my formula. So my perimeter is 18 times 6, because there are 6 sides, or 108. So 1/2 my apothem, which is 9 root 3, times 108. We multiply 1/2 times 9 times 108. That's 486. The square root of 3 comes along for the ride, and that is in square centimeters. So again, if you can get an exact answer, you absolutely should. All right, I would like you to try this one. Press pause on your video, and when you're ready for the answer, press play again. You can see that I've drawn my isosceles triangle within my equilateral triangle. Seems a little strange that I have triangles within triangles, but you can imagine, it's not drawn to scale at all, but you can imagine that is the bottom isosceles triangle of your equilateral triangle. First, I found the vertex angle by doing 360 and dividing by 3. That was 120. Then I drew in my apothem. And I recognized that I had to find the side so that I could find the perimeter. I was given the apothem, which is 5 root 3. So that's across from my 30-degree angle. Remember, this is A root 3, 2A. So A is 5 root 3. This side has to be 5 root 3 times root 3, which is 5 times 3, or 15. Then the side length of my polygon has to be double that, or 30. Now I'm ready to plug in to find my perimeter. My perimeter is 3 times that because there are 3 sides. So that is 90 meters for my perimeter. Plugging into area, I have 1/2 the apothem, 5 root 3, times the perimeter, 90. So that's a half times 5 times 90, which is 225. The square root of 3 comes along for the ride. And again, it's area, so it's square meters. Here is my final example I would like you to try. There's a typo here. This is not square kilometers. So I want you to find the area of a regular hexagon with a radius of 10 kilometers. Press pause on your video when you're ready for the answer. Press play again. So you can see I have drawn my isosceles triangle that's within my regular hexagon. I found my vertex angle. My vertex angle was 360 divided by 6, or 60 degrees. I found my base angle by doing 180 minus 60 all over 2, and I got 60 degrees there. I drew my apothem, and I found a gorgeous 30, 60, 90 triangle there. Now, I was given that the radius is 10. Here, remember the relationship. This is 2a, this is a, this is a root 3. So if I know 2a is 10, I know that a is 5. So this part here is 5. My apothem is 5 root 3. Now I would like to find the perimeter. To get a side length, I have to multiply by 2. That gives me 10. And then I have to multiply by the number of sides of my polygon, 6, so my perimeter is 60. Now I'm ready to plug into my area formula. It's 1/2 the apothem, 5 root 3, times my perimeter of 60. So 1/2 times 5 times 60 is 150. Square root of 3 comes along for the ride, square kilometers. So now you guys should be expert at calculating the area of polygons, and it's time to practice.